Hi guys, today we're looking at exercise 19.1 again. Our learning intention for today is to be able to solve problems involving 2D shapes and distance, speed and time, and solve problems involving scale diagrams. Let's look at an example question. This is exercise 19.1 question 10. A satellite orbits the Earth at a distance of 1,250 kilometers above the Earth's surface, and the Earth has an approximate radius of 6,400 kilometers. If it takes the satellite 2 hours to orbit the Earth, calculate the speed and let pi equal 3.14. Okay, so we want to find the speed. So we're going to use Daddy's silly triangle to find a formula for the speed. So speed is equal to distance divided by time. So to find the speed, we need to find the distance that the satellite traveled, and we need to find the time it took it to travel that distance. Well, we know that the satellite is traveling in a circle. So the distance it travels is the circumference of the circle. So it's traveling one full circle. That means the distance it travels is the circumference, which is equal to 2 pi r. And the time it takes to travel is the time it takes to make one full orbit. So the time to travel one orbit. That means your speed is equal to 2 pi r divided by the time to travel one orbit. So now we need to find what r the radius is. So the radius in this case is the radius of the Earth plus the distance that the satellite is above the Earth's surface. So we need to look at the dotted circle, and we're finding the radius of that dotted circle. So that's going to be the radius of the Earth plus the height above the Earth's surface. So the radius for the circle is 6,400 plus 1,250. That means the radius of our circle is 7,650 kilometers. And the time to travel one orbit is given in the question. We're told that the time to travel one full orbit is equal to 2 hours. So now we just need to substitute these values into our formula and solve for our speed. Our speed is equal to 2 times 3.14 times 7,650 all over 2. That means our speed is equal to 24,021 kilometers per hour. So we know our unit is kilometers per hour because our distance is measured in kilometers and our time was measured in hours. Okay, let's look at the rest of the question. We're told that due to space debris, the satellite is moved to a new orbit further away from the Earth. It now takes the satellite 5 hours and 18 minutes more to orbit the Earth, traveling at a speed of 16,000 kilometers per hour. Calculate the change in the distance above the Earth's surface. So we want to find distance. Again, let's use Daddy's silly triangle to find what our formula for distance is. So Daddy's silly triangle, cover your thumb with the letter you want to find, which means that distance is equal to speed times time. So the distance traveled is equal to the speed times the time. All right, we know what the speed is. We need to find the time it takes to travel this distance. So we're told that it takes the satellite 5 hours and 18 minutes more to orbit the Earth. That means the time it takes to travel this distance. So we have a satellite that's further out. The satellite is moved further out. So the time it takes to travel this distance is 5 hours and 18 minutes plus 2 hours, the original time it took the satellite to orbit. That means the time it now takes the satellite to make this orbit is 7 hours and 18 minutes. Now we can only do our calculations when our time is in 1 unit. So I'm going to change my minutes into hours. To do this, I put the number of minutes I have over 60, which gives us 18 over 60. 18 minutes is equal to 0.3 of an hour. This means that the time it now takes the satellite to orbit is 7.3 hours. And we know that the speed that it's traveling at is now 16,000 kilometers. We need to find the distance that it travels, i.e. you want to find, let's just draw that out again. So your satellite is here now. You want to find the distance that it travels, i.e. you're looking for the circumference of the circle. So our orbit circumference is equal to our speed times our time. Our orbit circumference is equal to 16,000 times 7.3, which gives us 116,800 kilometers. So our orbit circumference is equal to 116,800 kilometers. But we're not finished yet. We want the change in distance above the Earth. So we are looking for the radius. We're looking for how much further above the Earth is the satellite now in comparison to what it was. So we need to find the radius of our circle. So we know that 2 pi r equals our orbit circumference. This means that 2 pi times 3.14 equals our orbit circumference of 116,800. Sorry guys, I should say or there. Okay, so we now need to find our radius. So we're going to divide by 2 times 3.14. So our radius is equal to 116,800 divided by 2 times 3.14. Our radius is 18,599 kilometers. This means that your satellite, let's just draw it again. So our satellite is now 18,599 kilometers. That's what the radius of it is. Okay, from the center of the Earth, it is 18,599 kilometers away. The question asks us to calculate the change in distance. So to find the change in distance, we're going to take our new radius from our previous radius, and the difference between these values will give us the change in distance above the Earth. So the difference in our radii is 18,599 minus 7,650. The difference in our radii is 10,949. Please pause and take down this question. Okay, let's try another one. A map has a scale of 1 part to 100,000. Calculate the scaled lengths that need to be drawn on the map to represent 1 kilometer, 14 kilometers, 125 kilometers, and 600 meters. All right, the first thing you need to know in these questions is what your scale represents. 1 part to 100,000 means that for every 1 centimeter you draw, it represents 100,000 centimeters. So when we want to find out the scaled lengths that need to be drawn for each of the given distances, we need to convert our units from kilometers into centimeters. So 1 kilometer is equal to 1,000 meters. To convert from kilometers to meters, we multiply our value by 1,000. Now we want our lengths in centimeters. I now need to convert my 1,000 meters into centimeters. To convert meters to centimeters, we multiply by 100. 1,000 meters times 100 gives us 100,000 centimeters. This means that 1 kilometer is equal to 100,000 centimeters. Okay, so we now need to see what is the scaled length that needs to be drawn to represent 100,000 centimeters. The first thing we do is write down the ratio given. 1 part is to 100,000. Underneath this, you write down your converted lengths and the unknown value. You're trying to find the scaled length for 100,000 centimeters. When you have your values on the same side, i.e. the number that is larger than 1, when these are on the same side, to find the unknown, you divide. So 100,000 divided by 100,000 gives us 1 centimeter. That means we need to draw 1 centimeter to represent 1 kilometer. Let's try another one. We need to represent, and I'm going to do this for 4 kilometers. First thing we need to do is change our kilometers into centimeters. This is because the scale given is in centimeters. Therefore, all of our distances must be in centimeters. If 1 kilometer is equal to 100,000 centimeters, then 4 kilometers is equal to 400,000 centimeters. Let's see what the scaled length needs to be. Step 1. Write down what your ratio is. 1 part is to 100,000. Then write down what you know. 400,000, and we need to find our scaled length. When your values are on the same side, we divide to find our unknown. Same side divide. 400,000 divided by 100,000 gives me 4 centimeters. This means the scaled length that needs to be drawn on the map to represent 4 kilometers is 4 centimeters. Let's try one more. 125 kilometers. The first thing we need to do is change your kilometers into the same unit as your scaled lengths. So we need to change our kilometers into centimeters. If 1 kilometer is equal to 100,000 centimeters, 125 kilometers is equal to 125,000 centimeters. Then write down the ratio that you're given. From here, write down what you know and your unknown. If your values are on the same side, to find your unknown, you divide them into each other. That's 125,000 divided by 100,000 gives us 125 centimetres. Please pause and take down this example. Let's try one more. A diagram has a scale of 1 part is to 2,500. Calculate the actual lengths of the lines represented as 3 centimetres, 12 centimetres, 10 millimetres and 0.45 metres. Okay, the first thing we need to look at here is what does our scale represent? 1 part is to 2,500 means that 1 centimetre represents 2,500 centimetres. We need to find the actual length when our scaled length is 3 centimetres. We follow the same steps as we have in the previous question. Write down your ratio. Write down your unknown and your known. 3 centimetres is to question mark. To find our unknown in this case, our values are on different sides. Okay, so you ignore the 1. Your values are on different sides, so we multiply to find the unknown. Different side, multiply. This gives us 2,500 times 3. 3 centimetres is equal to an actual length of 7,500 centimetres. And if you want to, you can convert this into metres by dividing your value by 100. This gives us 7.5 metres. Okay, so if your values are on different sides, to find the unknown, you multiply. Please pause and take down this example.